Welcome to another episode of EduSmart's Professional Development Series. Lisa today has a jam-packed session for us, so I'm going to keep my intro as short as I can. I'm just going to go ahead and introduce our lady of the hour. Lisa is the curriculum director of curriculum and professional development here at EduSmart Science. She is known for offering challenging, creative, hands-on science educator workshops. She has over 34 years of experience in science education, with over 25 years of presenting at conference sessions, workshops for science teachers all over the state. Before joining EduSmart, she has worked as a classroom teacher, a department chair, an online certification teacher, virtual school curriculum designer, independent science consultant, and science curriculum director. Basically, if there's anything science related in education, Lisa has most probably done it. Without further ado, please give your warmest welcome to Lisa.
Thank you, Devanchi. And Devanchi's going to be monitoring the chat, so feel free to type in the chat if you have any questions as we go, and I will address as many of them as we have time for. What we're going to talk about today are driving question boards. Driving question boards are a strategy used when you teach with a storyline. So what you do with a driving question board is it's a way for students to generate, keep track of questions and revisit questions that drive the main investigation that you're planning on doing for your unit. The big idea behind a driving question board is that it should be publicly displayed. This can be in your classroom on a bulletin board, on big chart paper. And in this case, since we are working remotely from each other, that we're going to do an online digital driving question board. And you're going to behave like students would, and you're going to generate questions based on media and pictures that I'm going to share with you. So the idea behind using a driving question board is to anchor learning to student questions, especially your lab investigation. I was in the classroom a long time. I've been out also quite a while, but I don't think students have changed. A lot of times when you do a lab, they're not connecting it to the lesson that you're teaching, especially if you're doing inquiry, because I would do a lab and the kids they didn't even know what the science topic was. And I would say things, well, why are we doing this today? Why didn't we do this last week? That you plan all of these engaging labs and the kids are not making the connection to the content. And so by using a driving question board, the kids come up with a question, you steer them toward the lab you want to do with the questions. And so the focus shifts from just learning facts or doing a lab that they don't understand the connection to try to figure out why or how something is happening. And so we're going to practice strategies today by introducing a phenomenon, and then you're going to be the student and come up with questions you have about the phenomenon, and we're going to do a driving question board to do that. So I have a very short video that I'm going to show you as our introductory phenomenon here. Okay, so we'll stop there. And so think about what questions you have or what questions you think students would have based on what you saw. What I have here is a link to a Jamboard that you can either grab the QR code with your phone if you want to keep it separate from looking at the screen. And Devanchi's putting the link to that Jamboard in the chat. And so I'm going to stop the presentation here real quick and move to our Jamboard about this. And so just so you can see how this works, we have a couple people who've already posted. But if you want to add your question, there's a sticky note tab over here to the left, if you can follow what I'm doing. If you click on that, a sticky note will pop up. I'm just going to type on it. If you want to change the color, you can do that. And if you press save, that shows up on the board. That's not a question, so I'm going to go ahead and delete it. But just to show you how this works. So what I want you to do is ask a question. We've got some good questions here to get started with. What other questions do we have? Okay, I can see we have 21 people here and not 21 people in the Jamboard yet. Okay, here's a good one. What's that white material? Okay, someone's using the marker tool. That's okay. Be sure to click on the sticky note over here. Okay, we're getting more people joining, so that's wonderful. Here we go. It's got an eraser here. I'm going to erase this. You can see. Okay. We have lots of questions about wanting to know what the white material is. Think about some other science questions that you could ask. Good questions. But the idea behind a driving question board is you want it to lead to a lab, a scientific investigation. And so even though some of these are good questions, oh, here's a good one. Is the water cold or hot? I think some of these are on top of each other. Nope, I'm going to move some of them around just so we can see. So let's think about which of these questions are the best at leading us toward doing an investigation. So again, some of them great questions, but we're trying to lead toward doing a lab where we can answer that. So here, do all raccoons react the same way? Great question. I'm not sure how accessible raccoons are to your classroom, but I would probably have trouble getting some to do an experiment with. I mean, you could probably do it remotely if you know someone who has a raccoon, but let's pay attention to the ones that we could answer in a lab. So what are some questions that would be good for that? So y'all also have the ability to drag. And so I'm going to put all the questions on one side. And if someone wants to drag over to the right, move one over here that you think you could answer in your lab. Okay, what materials dissolve in water? Could that be something you test? Absolutely. What makes something dissolve? Excellent. I see one more from what's on here that definitely could help. And one of them that you could tie into an experiment. This one, does everything dissolve in water, is a really good question. And this one, is the water cold or hot? We can't answer the question about the video, but we can answer the question of, does having hot or cold water affect whether something can dissolve or not? But these are all really good questions. You don't have to spend an awful lot of time. This is plenty. What you can do then is have this board accessible and let the kids keep asking questions. Like even after you do your initial activity, maybe they'll come up with more questions and they can go back and add it to their driving question board later. But you see how I'm open to all questions, but you need to kind of steer and drive the questions toward one that you could answer by doing a lab activity. So I'm going to go back to my PowerPoint real quick. Don't worry, we're not through with driving question board examples. Let me get it back into presentation mode. And we'll go here. So the purpose is to lead students to doing an activity. And I know we have teachers here from both Texas and Florida. So what I try to do are find standards that we have in common. And maybe an activity that you all could do and have in common. If you're an EduSmart customer, of course, you have access to our simulations. And in grade 5 in Texas and also grade 5 in Florida, we have this simulated lab activity called Properties of Mixtures. And what the kids do is they conduct an experimental investigation to determine if different materials, when mixed with water, will maintain their size or dissolve. And based on the questions that were asked in the driving question board, you could start with this, move on to an actual wet lab in your classroom, and maybe repeat it with similar materials and use water of different temperatures. Or use the similar materials, but use water and something that's not water, so that you could answer the question, does everything dissolve in water, or does water have to be there for something to dissolve? We don't really teach the level of solubility that you would learn in high school at 5th grade, but you can do a lot of science just starting with an idea of raising questions about properties of materials that dissolve, with both the material being dissolved and the material that's doing the dissolving. So I'm going to pause before I move on just to see if we have any questions, because I see there's stuff in the chat. Devanshi?
There are no questions right now. Yes.
Okay. Anyone have a question or an idea for a lab that maybe is something that I didn't mention? You can see that the standards, even though they're both about dissolving, that the focus is a little bit different. So the 5th grade one here in Texas talks about dissolving a solid in a liquid or a liquid in a liquid. So you could gear, after you do the simulation, you could gear your other investigations into making sure you at least have an example of a liquid dissolving in a liquid. And in Florida, our standard looks at conditions that will speed up or slow down the dissolving process. And temperature is definitely a factor that can speed up or slow down depending on if your solvent is hot or cold. And that's addressed somewhat in the simulation, if you're familiar with it, because all of the materials they use in the simulation are not the same size. And so they grind up some of them so they end up all with the same size. And so you could go a different direction in Florida, looking at things that affect how fast something dissolves. All right. I'm going to move on to our second example, which is just a still picture. So this is a different Jamboard, so it's a different link. And again, Devanshi's going to share it in the chat. So you can either click on it or you can grab the QR code with your phone. I'm going to leave this up here for just a minute in case people do want to grab this with their phone. And this is just a link to a different Jamboard. I'm seeing more stuff come up in the chat, so if I need to, I need to move this so I can get to it. Here we go. So we've got a few people in here already and one question already here. So what's going on in this picture? What questions would a student ask about this? Okay, got some science here. How fast was the truck traveling? Is speed a factor? That's a good one. What pushed the truck over? All right, I'm just gonna, was there a high wind? Does the weight of the truck affect the speed? These are all good questions. I'm just making sure we don't have stuff. Yep. What caused the truck to flip on its side? Okay, we've got a lot of sort of physics questions here. What force caused the truck to roll over? What happened? Is the sand loose? Okay, let's look at this from a different lens. These are all great questions, but just because I know what content we're moving toward, let's think that if you have a question that could be related to, let's say, biology or environmental science, would that change the type of question that you were asking? And just in case we have more people, who have joined, who missed the first Jamboard, all you have to do is click over here on the left at the sticky note, and it will pop up on the screen and you can type in it. There we go. What were road conditions like? Did anything hazardous spill from the truck? That's a good question. I like that question. Is the truck carrying dangerous material? Is there one underneath here? No, okay. All right, any more questions? I will let you know if you set up your own, if you want to do this digitally on a Jamboard, that you can add blank frames after that. So if you run out of room on the first one, you can always drag the Post-it notes or just have kids click to the next slide, and you can keep adding them if you need to. So this occur near a city or town, how would that affect all of these questions? So you can see that we got better questions this time that were more related to science rather than just curiosity. I guess what was inside the truck is another good one. And as the teacher, my job is to steer you toward the interpretation I want you to get from the picture, because I already have a lab picked out. And ideally, in an ideal world, how these storylines work is that the questions the kids generate are supposed to lead to an investigation, and you're supposed to magically have everything on hand to answer the question the class decides to answer. But the real world doesn't work that way. And so I'm telling you to sort of focus on, oh, that's a good question. I think we could do a lab with this question, so that they're geared toward the lab that you already have all the materials for and are prepared to have them do. So I'm going to go back to my PowerPoint and show you that I wanted to lead you to an activity about what happens when humans have an impact on groundwater and surface water and water quality in their environment. And so this one is also, I'm just going to, as my example, link to the human activity on watersheds example, which is a paper and pencil model that's inside of EduSmart at grade 7 in Texas and also grade 7 in Florida. So our standards don't always line up, but for this one it does. And so when you do this activity and you add something to the surface water or the surface, the kids will understand that it can contaminate the groundwater below, and they all can connect it back to that picture that you started with. Because a lot of times we try to connect labs to their everyday world, but kids don't have the same experiences in their everyday world. So starting with a video like the raccoons, or starting with an image like the truck that tipped over, everybody can connect their learning back to the same experience. And so that's the beauty of storylines and having kids see science rather than as a whole bunch of facts they have to learn, that they see science as a way to answer questions and to solve problems. So we're going to do one more. But before I move on, I want to talk a little bit more about phenomena itself. So the phenomenon in these examples were the video of the raccoon and the picture of the truck. And so what a phenomenon is something where you have to use scientific knowledge to either explain, predict what happens next, find a pattern. And so it can be almost anything. Something is eating the honeybees, and so we have to figure out what's going on. or Kara made some homemade bath bombs and they're not dissolving. And so it's a way for you to, it's an example for you to explain some type of scientific process. It's not an explanation. It's just a way for them to all experience the same story. And by centering on something they're motivated to explain, something they're curious about or that they wonder about, again, the topic or the learning shifts from having to learn a bunch of facts about watersheds to try to figure out what would happen if that truck was filled with something toxic. What would happen? And so they have a story rather than just facts to connect it to. And so I talked a little bit about this earlier, but sometimes if you just do a lab right after you do your explain part of your lesson, kids don't make that connection. You could talk about photosynthesis for 2 days, do a lab on photosynthesis, and they don't even connect the two. So I use this picture. I taught biology for a really long time, and it was amazing how every day is a new day, and they don't connect anything they do to prior learning. But if you use this storyline and you connect everything back to that original phenomenon, then they're going to remember it better. And so it helps them see why they're doing the lab. We're doing the lab to answer the questions that you came up with, and that's what we do in science. And so the point is for them to develop the knowledge along the way by doing the lab activity that they can either explain the phenomena or predict what might happen next in a similar situation. The focus is not on the phenomenon itself, but on the student-generated questions that come out of that, and you make the kids think they're the ones driving the learning, even though you've already picked out the lab. They don't know that. And so they think they're answering their own question. And so this practice of asking questions and identifying problems, that's just what you have to do to figure something out. And so there are some steps to doing this, and we're going to go through each of these individually, and you're going to get a copy of the slide deck in case you want to share this with other teachers. That first you explore, you look at that anchoring phenomenon and you say, what do we notice? What kind of questions do we have? You attempt to make sense of this. Is there some way we can explain what's happening or do an experiment that could model what's happening? If you can also try to connect it to something else. Where does something else like this happen? And what else do we need to do to figure out or explain what's going on? And so the driving question board, again, is what drives the storyline, that you have the anchoring phenomenon, you create this driving question board, and you let kids think that they're the ones leading what the investigation is going to do. And so our last example, we're going to go through the multi-step process rather than just the first one, which is what questions do you have? So this is our last Jamboard. And so we have a picture here of a fish. And I want you to think about questions you have about what you see in the picture. Again, I'm going to leave this up with the QR code in case you want to grab this with your phone, but Devanshi's putting the link to the Jamboard in the chat. So I'm going to wait a few minutes just to make sure everyone's grabbing this if they're using their phone. And then I'm going to go to the Jamboard I have about this. Okay, we already have some good questions. What is coming out of the fish? Is the fish still breathing? Is the fish dead? Did the fish have babies? Is the fish alive? These are all really good questions. Maybe think about all this stuff that's coming out of this fish. What does it look like? Could this be, and then someone fill in the blank. Could this be, what is that? Are those eggs coming out of it? Okay, lots of questions about eggs. I'm going to kind of group those together down here. But what is the stuff? Is that glitter? So this is someone thinking that it's not something natural. That's a good question. What else do you think it could be? see, we have this same question again, so I'm just going to put it on top. Did the fish eat something plastic? Oh, that's a really good question. What would happen if a fish ate something plastic? Could it be something toxic that the fish ate? What is that animal? Okay, it's a fish, so still a good question. And depending on the age level of your students, you'll get questions that are not really related to the topic at hand, and you can just, all of these questions are all related. You'll get, what happened to the fish's tail? Yeah, it doesn't look normal, or I don't know if it's just the picture. Did the fish have babies? That's kind of related to eggs. What else do you think this looks like? And so let's talk about, here's some questions that we have. The next part of this Jamboard was, how can you explain this? How can you test it? So if we thought that this was glitter or something plastic, do we know what happens to something like that's man-made, like glitter or plastic, when you put it in water? Okay, so a good question could be something like, does plastic dissolve when you put it in water? Can you get plastic out of the water? So you may have to, again, I went from here to here by clicking this next frame. So if you're not seeing what I'm seeing here, oops, you'll just have to click the next button. So these can be more questions. So I'm going to wait for people to populate this, making sure there's not one over here. Okay. Everyone, no one having issues getting to the next frame? There we go. Can we check its temperature? Something along the line of following food chains. Okay, I like that idea. Is that stuff glowing, or is it just the lighting? I didn't take the picture, but I'll answer that one. My best guess is it's the lighting. But I know what it is, so. Okay, did anyone pick up on the question that I was asking? I didn't put it on a Post-it. Is the material biodegradable? Okay, and what do we think the material might be? Okay. Like I said, I liked this idea of something along the line of following a food chain. So what about, how would this get into a food chain? Would that be a good question? Feel free to take my question or statement and copy it. I just want y'all to have a chance to participate. How did stuff get into the fish? Okay, this goes along with the food chain idea. What did the fish eat? How would this enter a food chain? These are all good. How would this affect the bigger fish eating it? Okay, now we're getting some really good questions. Okay. And so again, I'm going to shift to the next frame. So you're going to have to go there too to add the Post-its to it. Where, well, I don't know what happened here. Where else does something like this happen? What do these structures look like? So I'm asking a specific question. Mainly, what do you think these look like? And even though you have an answer, this one was phrased in the form of a question. Does it look like anything you've ever seen before? There we go. Beads. Okay. They look like round pellets, maybe oil droplets. COVID. It's a little big for a virus, but yeah. The toad life cycle. Okay. I'm talking specifically about these structures here, the ones that look shiny because of the light. What are these? Any other guesses? Just want to make sure there's not some under there.
This is Juan Gutierrez, and my questions are not populating, but
Oh,
yeah, for some reason it's not connecting.
okay. I'm
But
happy
I
to put
was
it for
guessing
you.
bones,
You were guessing bones?
maybe bones or something.
Okay. Okay, I'll do it for you. I'm so sorry that it's not working for you.
Yeah, it did on the first one, but
Okay, that's weird.
yeah.
There was some more beads, some bones, eggs, sacs, nutrients. Oops. So anyone else? Caviar is really like eggs. I'm gonna put that there. Desiccant beads from a shoebox. That's actually a pretty good guess. You know those little packets of chemicals they put in there to absorb moisture? It does look like that. Okay, and then if we click the next frame one last time, what would you need to be able to know to explain this? And this is the last slide. I think they're just blank ones after this. And I've been trying to guide you toward what you need to know its chemical composition, anatomy of a fish, location of the fish. Did the substance kill the fish or is it natural? I like that question. Oh, I don't know how that happened. I think I opened it. The surroundings of the fish, its location, what that round shiny stuff is. Yeah, exactly. Yeah, you can't explain it if you don't know what it is. So do we have any guesses, any more guesses as to what you think it might be? I tried to steer you toward what I thought were good answers in the last one. Is it living or non-living? Does it taste good? Okay. I think you understand I'm steering you toward that this is not something natural that the fish would normally eat. And so a good question would be, why is it eating them? Okay. But we'll stop there for now and I will share, is it a parasite? Okay. Go back to the PowerPoint. And I jumped ahead. What lab could students do to learn more about this? And so just like the other examples I used in a driving question board, you have to have the lab in advance. Otherwise, you don't know how to steer them toward the lab that you already have the materials for. And so you can just keep letting them ask questions till they get to the point where you feel like they could make the connection to the lab. And I think we are probably at that point where I could introduce the lab I want to do, and you're going to tie it back to this fish picture and the storyline when we do it. So there's a problem, and the problem is that these little shiny round things are microbeads that are found in cosmetic products. They're the same size as some fish eggs, and they look like food. And so if fish eats the microbeads, this plastic can end up in the food web and onto your dinner plate. So now, what kind of questions would you have knowing this information? What activity or what questions do you think kids would have? So you can either put that in the chat or you can unmute yourself. And what kind of questions would kids want to know if you gave them this information here on the left? Anyone want to jump in? I would think students will want to know what products are these microbeads in, right? And can you test products to see if they have these microbeads or microplastics in them? And the answer to that is yes, because they are not soluble in water. They're large enough to see with the naked eye, and you can actually quantify how many microplastics there are as long as you start with the same volume of materials that you test. And so what Devanshi's going to share is like a one-pager inquiry type activity where the right side of my screen is the top part of the activity, giving them some background information. They used to have a lot of these in toothpaste as well, but the toothpaste industry has decided to replace it with sand instead of using microbeads that was there for to scrape stuff off your teeth. But a lot of facial cleansers still have these plastic microbeads. And a lot of times if you just pick up the bottle at the store, if it's a clear container, you can see them inside. And there are estimates that over 8 trillion of these microbeads enter our waterways every day. And so my favorite way to do a lab is not to give the kids directions, but to give them a guiding question. Tell them you can use any of these materials and think about what data you need to collect. And then I would have them show me their data table before I would let them come and get the materials, just to make sure they thought through and are not running up to the front of the room to grab stuff before they know what they're doing. So the question is, can you develop a method to remove as many plastic microbeads as possible from samples of face wash? So if you want to quantify how much is in there, you're going to have to separate it from everything else that's in that product. And so you need at least 2 or 3 samples of face wash, water, filter paper, some plastic cups, some safety goggles, of course, funnels, a balance, and maybe a graduated cylinder to measure volume. And so you make them think in small groups about how can you collect data that gives evidence that microbeads are present or not present? How will you measure how much microbeads are in a sample? How do you know when you have enough data that you can stop collecting it? How can you make sure that your data collection is consistent? And then how can you reduce error or any kind of outside factor that would influence your results? So I think I've done this with students in 4th grade and up, and they have not had any trouble figuring out what they're supposed to do. But it may depend on how often your kids do labs and are used to using things like filter paper and funnels. They may need a little more background if they're not familiar with that. Any questions about how I use that phenomenon to drive a whole lot of questions on a storyline, and then again, knowing that we're ending up doing an activity about it? And they're going to connect this activity to the fish because they came up with so many questions about it, especially this time around. All right. So for this particular one, I found standards in Florida and Texas that this topic kind of shows up at 4th grade and 7th grade in Florida and at 5th grade and 8th grade in Texas, that you could use it if you were teaching any of these topics. I have some other examples of driving question boards that are the paper kind that someone did in their classroom. So these I just found on the internet, and you can see your kids use Post-it notes to add questions to basically an anchor chart here, where the teacher set up sort of a lab setup, and then the kids ask a bunch of questions about it. This one's a little more elaborate, where their ideas are on the left, their questions are in the middle, and then what we figured out is at the other end. So it goes beyond the driving question board to the whole storyline here. But you can see you can cover a lot of different science just with this question. Here's another one. Why did dead things disappear over time? And you can see the kids' questions that they have about that. or how do interactions between air, land, water, and living things contribute to flooding? So this is a huge question, probably a unit question, and you could tie in more than one science standard to this. So your role as a teacher is to steer them or help them understand, is the question a good question? Does it address the phenomenon? Is it something that you can address through research or an experiment? And if you do figure it out, are you going to have factual and measurable data and not just an answer based on opinion? I'm going to skim through this next part really, really fast because we're running out of time. But cross-cutting concepts can help frame the questions. It can help you decide what phenomenon also to pick. And for those of you in Texas, our new TEKS at K-8 have cross-cutting concepts that are going to be in what we used to call the process skill part of our TEKS. So you're going to have to address all of these, and I'll have more webinars about this so that it doesn't seem scary, and I can show you how to incorporate it into your class. So if they can't come up with questions, this is what I'm saying. How can this be explained? Do you see a cause and effect? Like with the raccoon, what was the cause? What was the effect? That this can help them if they're having trouble coming up with questions. So what happened? The raccoon put the cotton candy in the water, and because they like to wash things off and make them wet, and the effect was that the cotton candy disappeared. You can also do structure and function. This one ties best to the plastics. Why did the shape of the plastic cause the problem? Its function was not to be food, but that's what fish thought it was. So this can help frame some of those questions. So if I had to pick 3 key points, storylines start with an anchoring phenomenon, and they're driven by student questions. And that driving question boards are an excellent way to document those questions. It can show how their thinking changes over time, and it can move students to a more focused effort on figuring out how to answer the question. So that by the time you get to the lab experience, their effort is all focused on the same thing. So I have a review slide, which I'm not going to read to you. This is just a quote I found. One student asked me, can we do this more? Even the students that normally have challenging behavior, they want to take over at the driving question board, which I found really astonishing. I wasn't expecting that, but that's definitely a win. So I'm also sharing from nextgenstorylines.org, which is from NGSS, their toolkit for using storylines. It has anchoring phenomenons and this whole creating connected investigations. And so when you get the slide deck, you can check out those links, or you can just go to nextgenstorylines.org and read a lot of information about using storylines. You can also search for driving question boards on Twitter or Instagram, and you'll get ideas that other teachers are doing. And so you can search the hashtag driving question board or DQB, and people post stuff all the time. So I want to thank you for coming. I'm going to open it up for questions, of course, but if you wanted to ask me a question afterward, you can always reach me. I'm down here on the bottom right. I'm Lisa at EduSmart.com.